just like boil off everything except the water, because some water will come with it. So we boil it off, and then it condenses, and then it can separate after that. That kind of makes sense? I mean, you're still probably going to have an amount of water in here, but I don't know. You can put sodium sulfate in that afterwards. Okay. Let's see what we've got. Okay. This is basically what I was going to put on your, like a practice problem, additional practice problem worksheet, basically. Because I want to get through to, I have office hours, what's today, Monday? I have office hours today after lab, so what, 1? Does lab end at 1?
We'll get out there and get it in.
Okay, cool. I will have office hours. My office is Revachol 825N. So if you go up to Revachol 8th floor, get off the elevator, and then you're like, where's the rest of Revachol? You have to go through these doors that are always closed, these double doors that almost look like it's into a room, but then once you open them, you're like, oh, okay, no, yeah, anybody can go through these. This just goes to a hallway. Pretty sure they're like fire doors, because they put all the organic people up here and up there. And that's generally why the organic people live on the top floor anyway, because we make the most fires, so if you're gonna make a fire, might as well have it up high so that only the top floor burns instead of burning everybody else, I guess. So you can come up there, honestly, whenever your lab is over, and we can go through things like that example, yeah, and other examples from the slides. So, acetals as carbonyl protecting groups. It is very useful that we can do this reaction, and then it's really easy to reverse it, right? Because it seems like, oh, okay, this is a reaction that we can do, and then if it gets really humid, or we just dump a bunch of water in there, we undo all the hard work we did. But that's great for protecting groups, because protecting groups, we put some stuff on there, and it is not what it used to be, and then ideally, you can deprotect with mild conditions that aren't going to like mess up whatever else you just did, whatever other chemistry you just did while that protecting group was there, right? So, okay, well, so what you do with this guy is, if we're trying to take this and we want, well, what, you want this to be a Grignard reagent, so, yeah, okay. We're gonna make that into a Grignard reagent, and we wanna react these. But this could attack itself, or, and 1, 2, 3, 4, okay, it's not gonna attack itself because it would make a 4-membered ring. Good call. But it could attack another mole of this, right? And like, that wouldn't be selective. So what we're going to do, yeah, okay. So when you're trying to make this reagent, you're basically, as you make it, it's going to react with this, like as it goes. You're not even gonna be able to get this reagent to put in with this anyway, to then get both reactions, because as you make this into a Grignard reagent, it's gonna start attacking other molecules of this right there, right? So, if you do, yeah, first we're going to protect this guy using, or turning it into an acetal. A lot of times we do cyclic because, I don't know, why not? Might as well. Make it a nice little ring. It likes to form, nature likes to form 5- and 6-membered rings. So we take this 1,2-diethanol. Yes?
How do you know when a cyclic acetal is going to be, like when it's going to form?
Oh, basically, if you've got two alcohols like on one thing, then you just sort of figure out what ring it would make if it did do a ring. And if that ring is a 5 or 6 membered ring, then yeah, that totally happens. And if it's anything else, not really.
Okay.
Yeah. So 5 or 6 membered ring, absolutely. Anything else, at least with this guy, not so much, just because you've got so much alcohol around that like it can just as easily grab just another molecule of this and have two. So like it's just as easy to separate. We can make rings that aren't 5 and 6 membered rings later with other things, with nucleophilic attacks, but like this just, I don't know, it's so reversible and there's so much of this around that you can just, it would be just as easy to make two. So it's just whenever it's energetic, whenever it's stable, more stable to make a ring, that it does that, which is this. So first, we get rid of our carbonyl and we protect it. I don't really like that they got rid of that H there, just because like, I don't know. If you have the H drawn out, it just disappears, whatever. So then you've got a cyclic acetal. Now you can take this guy, turn it into a Grignard reagent, because this isn't going to do anything. Then you can react your Grignard reagent with, oh, okay. I was like, where's the Grignard reagent? You can, turn this guy into a Grignard reagent. I guess in the same step, they're adding the benzaldehyde, so that it attacks right there already, and we've got that. And then when we do our workup, right, because this guy lives like this, we haven't actually finished, like that's a negative charge. I don't really care if you put the MGBR plus there, that can just disappear for all I care, because metals, we don't care about them, right? But the oxygen has a negative charge, and it's still going to have a negative charge until we do the workup. The workup of a Grignard reagent is water and acid, right? And so if we add aqueous acid to work up this, we're going to go ahead and protonate our alcohol, and we have enough water that we're going to do that. We're going to kick off the alcohol again and reform our aldehyde. Make sense? Very convenient protecting group. And I don't know why this 5-membered ring is like that. The 1,2-diethanol is what everybody uses. I don't know. It's probably just easier to have. No, I feel like I use methanol and ethanol as solvents a lot. Isopropanol, yes, sometimes. And then you get up higher in butanol. Maybe it's just more expensive. So we use lower carbon. I don't know. Also, butanol smells bad. So there's a chance that if you added if you have 3 carbons there, so that your protecting group is a 6-membered ring, I don't know. I don't really know why people use this and not the other one. They also use the other one. It's just, I don't know, this is the one I always see. Okay. Which of these is an acetal? Is 5 an acetal? Is 4 an acetal? Who says yes? Who says no? Okay. Is 3 an acetal? Tell me out loud.
Yeah.
Okay. Is 2 an acetal?
No.
What is 2?
Hemiacetal.
Yeah. We've seen that before. It looks similar. 1 is 1 a hemiacetal, or was 1 an acetal? Yeah. So that one, I guess they're just trying to trick you, like, oh, you're supposed to look for 2 things on there, and they hit it with a ring, but it's there. Okay. Addition of nitrogen nucleophiles. We've got 10 minutes. Let me see how many probably. You know what, we'll start it, and if we don't make it all the way through, it's fine. We'll just restart it tomorrow, and for the first half of the mechanism, you guys will be, no, actually, I've got a better idea. If we're not gonna make it through that, let's go do some of the example problems from the slides or something. Yeah, better idea? Is that a better idea?
Yeah.
Okay, I thought so. Cool. So I don't want to go halfway through All right, let's see. We can do this one. Are you guys interested in doing this one?
We can't see
I
it.
can't see it.
Oh, okay. Fix it. Do you want to do that one? Do you guys want to go, so this is, do you want to do an example of stuff we did today, or do you guys want to do an example of stuff we did previously? Raise your hand if you want to do an example of today's stuff. Raise your hand if you want to do an example of old
Is
stuff.
today's stuff going to be on the quiz tomorrow?
Yeah. Yes. Let's go with yes. Yeah. Is that okay? To have the day before lecture stuff on the quiz?
Yeah.
I'm trying not to have that, well, I put all your exams on Mondays anyway, so that there's plenty of time, and I tried to put it so that we would hopefully finish the stuff and be able to start the next stuff before then. But yeah, that seems fair, right? That can be on your quiz?
Don't we have
Okay.
another quiz on Thursday?
Oh, you do have another quiz on Thursday.
So could we do today's stuff on Thursday?
Yeah,
And then go over
yeah,
the
today's
other
stuff
stuff?
can go on the Thursday quiz, because I wanted 5 quizzes, because, I don't know, I wanted to be able to drop one. Like, I like being able to drop the lowest of whatever I can.
That
So,
way we just have time to like rewatch the videos and whatever.
yeah, that's a really good idea. Okay, yeah, let's go over some older stuff for quiz purposes.
And that way anyone who missed class has time to like watch the video.
Yeah, that's a good idea. And that way we can start on it, you guys can start it, and raise your hand if you want to do a chapter 15 organometallic thing. Up high. Raise your hand if you want to do a chapter 16 thing. Okay, let's try a chapter 15 thing. Raise your hand if you don't care. You're just like, just do something, because we're running out of time. We can't be late to lab.
We vote for your preference, whatever you think's more important.
Fair
Considering you're
enough.
writing the quiz.
All right, let's see. Where's your example? Did we do 1-phenyl-3-hexanol? Did we do this one? Because we actually did some of these in class.
I think we could.
Okay, I thought we might. Did we do? Did we do this one in class? 1 bromocyclohexene to 1 methylcyclohexene. Did we do that? I feel like we did not. Okay, yeah, let's do this guy. So, bring about each conversion using a lithium diorganocopper reagent. So I don't care about, oh, yes.
Are the quiz questions or the exam questions going to be formatted like this, or will we be able to like see the actual structure, or will we just be given the name?
So I prefer giving you pictures. Like, I think See, I don't want like a problem worth many points to be like, if part of the problem is can you draw the structure from the name, then that's just more work for me to give extra credit because I still want to give you points if you can do the concept, just if you start with the wrong thing, I mean, that's only so many points, right? So I think I might put like a couple naming things on there for funsies because my old exams don't have any naming because Paolo never taught naming and we've got so much content in Organic Chem 2 that I can't teach naming from scratch, so I just, screw it. But yeah, no, I like giving you pictures. And especially when your practice exams are pretty much gonna be all pictures because, well, they came from last year and I didn't make them do that. So 1-bromocyclohexene. Cyclohexene looks like that, right? One has to be one of these guys, yeah? And it really doesn't matter. Whichever one we put the bromine on, that becomes one, right? We're gonna turn this into one methyl cyclohexene. All right. So we can use lithium diorganocopper. Yeah, basically, lithium diorganocopper does something that Grignard reagents didn't do, right? It makes you able to take a couple to a halogen, right? A halogenated carbon. You replace a halogen with a carbon. Can we do that with Grignard reagents too? Yes-ish, if we add copper as a co-catalyst, I think. Yeah, so we had a couple examples of that. It's just important to know this too because a lot of times when you actually get into doing the chemistry, it's a Tuesday and there's a full moon and I don't really feel like figuring out why I didn't get this because making this thing isn't my chemistry. My research is doing something with this, so I don't care. Sorry, I'm wasting time. All right, so what does this look like? How many carbons are we adding? One. CH3. What does a lithium diorganocopper reagent look like? CuLi, right? What am I missing? Yeah. So, lithium diorganocopper, I looked up what this looks like. So, basically, it's copper with your R group, two R groups. And then what happens is that these guys do that, and then these guys have ether stabilizing it. So it looks like this. So basically, lithium diorganocopper, just my eraser. For all intents and purposes, if this is a way that you don't like doing this, you can just, or you can do that if you want. Does that make this guy make more sense? Okay, cool. Just make sure that you've got a bond going through your parentheses if you do this, because that will help you keep track of carbons. Did that make sense? Okay, it's probably time to go, because you don't want to be late for lab. Trust me.
For that,
What's up?
what is the nucleophile and